last lecture we focused on the aspect of fly ash in bricks, and you can put fly ash in clay and things or others. And then I thought this is a tutorial, so I thought it will be better to go a bit further in the tutorial about this 100% fly ash bricks that has been made and patented by an Australian UNSW academic who works in the defense thing. It's a very interesting paper, and it's available there. And this paper was presented in a World of Coal Ash conference some about 10, 12 years ago by them. And that conference, WOCA, is a very well-known conference. And then later tomorrow, I'll present one of our work, which polymer, fly ash in polymer, which was presented in a similar conference about around 2010. That I'll do in in a file, okay? This PDF file of slides. But this one is available online in the website. But WOCA is a World of Coal Ash conference. It's related to coal ash, and this conference is held in USA, and it's a very established conference. It says high performance bricks from fly ash. It was by Obada Kayali and School of Aerospace. Civil and Mechanical Engineering, University of New South Wales, and the Australian Defence Force Academy, Canberra. And the keywords are fly ash, bricks, compressive strength, lightweight, absorption, high performance, tensile strength, durability. So in theory, these are the things which we covered for in theory, but this is now, these aspects are now shown how all these things have been incorporated in these fly ash bricks or flash bricks, okay? So from that point of view, this directly gives us more information and more knowledge of how to do things. Now, bricks whose solid ingredient is 100% fly ash have been manufactured. They have been manufactured using 100% fly ash. The manufacturing process uses techniques and equipment similar to those used in clay brick factories. So in the past lecture, we went through the theories, the things, and now it will be good to see how all those theories have been merged into practice, and these 100% fly ash bricks have been developed and in fact patented and also now created. The bricks produced here were 28% lighter than clay bricks. So that was the number one. And then the bricks manufactured from fly ash possess competitive strength higher than 40 MPa. What is 1 MPa? You have idea? Okay, what is the strength of what is the strength of epoxy? What is the MPa about? What is the strength of polyethylene or polypropylene? So 40 MPa is about the strength of like some of the strong epoxies, PMMA. PMMA strength is about somewhere in lower around that. Okay, so but 40 MPa is not very high compared to other ceramics, but it is still a good value for bricks. Okay. This exceeds some of the best load-carrying clay bricks available by more than 25%, and it is several times better than acceptable commercially available common clay bricks. So, the other important characteristics of the fly bricks have been evaluated, and these include absorption capacity, initial rate of absorption, modulus of rupture, bond strength, and durability. So these are the essential properties of any brick, and this work showed that all these properties have been evaluated and the results achieved are very acceptable. From that point of view, the value of these characteristics for fly ash bricks are excellent and have exceeded those pertaining to clay bricks. Moreover, fly ash bricks have been produced with a naturally occurring reddish color similar to that of normal clay bricks. That is important because the bricks with reddish color is quite attractive. So here, all people wearing dresses with reddish color reflect more light. So I can see their pink color, I can see reddish color here, I can reddish color, I can see reddish color there, reddish color, okay? So I don't have any reddish color. My hat is dark, so you cannot see me, all right? But if I would have put on a reddish hat, then you would have seen me. But it's just a reflection of more light. So you can see reddish color. The new bricks and process have been patented, and the new bricks have been given the name flash bricks because it's made in Australia, so it makes it shorter. Fly ash bricks, 3 letters becomes 2 letters or no 1 letter. 3 letters fly ash bricks become flash bricks. All right. The new bricks and process have been patented and given the name flash bricks, and this paper presents the results of testing and advantages gained by this type of bricks over conventional clay bricks. So this one is as a tutorial. That means we don't have to go through theories again, but what we need to do, we will see what and how things have been achieved. Now, the ever-increasing volume of fly ash quantities in the world has not been remotely matched by its utilization. The most important and popular use of fly ash in Australia has been the partial replacement of Portland cement. Now, different countries have different attitudes. So it is natural that the brick industry presents an opportunity for the efficient utilization of the vast quantities of fly ash. As in one of the previous lectures by Dr. Hemlata, you heard that a lot of fly ash, a lot of coal power stations are coming down, but still the amount of coal energy is going up. So that will continue to be there because it is the easiest way of doing things. The other alternative that Dr. Hemlata mentioned is solar energy, okay, also wind energy. Now, as it happens to be, the world's best solar energy scientist and researcher is also in my university, one of my colleagues, Professor Martin Green. And they have used solar technology, and in one of my projects involving 6 Australian professors and 6 Indian professors, we had actually generation and evaluation of nanocomposites in energy generation and reduction of other things. And there he was involved in the silica-based clean energy thing, where they introduced not only just normal silica but also nanosilica. Okay? So those things can be done, but somehow or other they are not expanding that that much by volume or by quantity. Okay? But I'm not an expert in that area, so I don't know why it's not expanding. Even in India, there was the time, I think, in West Bengal, there is Sundarbans, and they wanted to use this solar energy, but somehow that it has been progressing, because there is a lot of technology involved and things, whereas fly ash is like coal burning. You may remember earlier, these days natural gas is used for cooking food. I'm not wondering whether it's home food or whether it's hostel food, but these days it's like that. But in earlier days, and even now in many villages, coal is burnt to generate and create food, and the rush comes out, okay? So it is much easier. It's just put the things and put fire and it will go through. Whereas other technologies, it takes much more time. And if sometimes, if whatever you do, if the sun does not come up for a few days, this solar energy, you have to go back to coal energy for those few days. Now, conservative attitudes are among the factors that limited the use of fly ash in concrete to generally a maximum of 25% replacement of Portland cement. So these things do happen. Okay, so we're going through the introduction, but we have covered part of the introduction there. Let's go to the brick production. The bricks produced according to the patent have been given the name fly ash bricks or flash bricks. Essentially, the only solid ingredient of the bricks is fly ash, or just the ash if you want to say. The main liquid ingredient is water. So you have fly ash or ash you are getting from the coal power stations, and water you can get from anywhere, all right? Other ingredients that so far are commercially protected are cheap, commonly available, and though essential, are only minor in quantities. So the main thing is fly ash and water. The technology includes the method of mixing, forming into molds, curing, and firing. It is similar to normal bricks, but the materials are different. These are easily adaptable by existing clay brick factories. So what the work says, go to the clay brick people and ask them to give you a chance of making these bricks using fly ash and water, but using those facilities. The technology uses less energy than that needed in the manufacturing of clay bricks. Remember, we found that the same thing there, that in the theory, at about 30% to 35% less energy. And here, the actual production of this brick and this patent shows that yes, that is achieved. Furthermore, it requires less manpower and less area is needed for materials processing than in the case of clay brick production. Now, manpower, as I had mentioned, in Western countries and certain countries, manpower is much more expensive than in India. So in India, we are much fortunate that we actually, so that many more people can be employed and things can be done. Okay, items of difference in the production process and expected to make cost difference. Now, if you take a look at common load-bearing clay bricks, the factory location is on-site of raw materials, whereas on the right-hand side, here, factory location on-site of raw materials, that is where you get clay, and like I said, it's much easier to do it on the bank of the rivers, provided the rivers, some rivers may have sand and some rivers may have clay. So it's best if you have close to two rivers, one river with clay, another river with sand, so you can take things from there. Whereas load-bearing flash bricks, you can do anywhere, but preferably on site of coal power station, so that fly ash is available there. Then factory location for clay bricks must change when material depletes. That means, if like I mentioned, the brick which I saw on the bank of the river Ganges, they keep on producing the thing, but after some time, they may have to shift to another side of the river. So that's a big shifting. Whereas, if you are using if you are making load-bearing flash bricks, you don't need to make any change, provided the coal power company is on. If that company is over or closed, then you have to, all right, but as long as this coal power company is there, that's okay. Excavation required, that means you have to pick up clay and all the things, clay or sand, so you have to put also this cost and effective thing there, manpower. But in the case of load-bearing flash bricks, you don't need to do anything, because you are getting the fly ash, and it is coming like powder or things like that in a truck. You take it directly and you put it in the system and then make the frames. All right. Raw material qualities, it says varies daily. That means when we are getting clay or sand, the clay depends on where the river water is flowing through. Some clays have some certain compositions, other clays have other compositions, okay? So, which is quite possible. How many of you have seen clays on the banks of any rivers? Have you seen? Okay. And what is the color of the clay? Okay, brown. And have you seen sand on any bank of any river? And what is the color of the sand? Light yellow. Okay. So those things are there, but once you keep on excavating, so to get more and more things, it will take time. So you have to keep on moving that. Okay. And raw materials quantities, qualities varies daily. That means depending on the clay, sand will be more constant, but depending on the clay, because it comes from different sources, so that might slightly or little change the composition of the bricks, chemical composition of the brick. But in the case of the load-bearing fly ash, if you are raising the fly ash from the same source, it will be consistent. But there may be always slight variations. Raw materials needed for 1,000 bricks, 4 to 5 tons of clay and shell, whereas it's about 2.75 tons of fly ash, so it's about 30% less. Raw materials wastage per 1,000 bricks, so 1.72 tons of clay and shell. So those things are wastage, so that means you have to throw them away or you have to reuse. But in the case of fly ash bricks, there is none. So fly ash, the bricks gives you all the properties, but it actually at the same time, the problems are much less. Worries are much less. The next thing is grinding of rocks. Yes, if you have to put rocks, because you have to grind them to smaller particle size. No, because fly ash is already very small particle size. So you can get as low as 15 micron, or you can get as high as about 100 microns, something like that. But the material is already, it's coming out from the coal pod or furnace. Additive, subject to provisional confidentiality, none. But in the case of the fly ash, you may need to have little bit of additives. Mixing dry materials, in the case of normal bricks, it is required because you have mixed clay and shells and all those things. In the case of fly ash, no, if it's 100% fly ash. But if you're using 50% fly ash, that's a different story. So this is, on the left-hand side, this is 100% clay bricks, and on the right-hand side, 100% fly ash bricks. Drying green units, 7 days. That means this is before curing, and here is 3 days. So your waiting period is much less. Temperature of firing units, not different. So if you have a company which uses the bricks using clay and shells, and if you transfer it into a fly ash thing, the temperature, the curing temperature is the same. So you don't have to change anything about the furnace. Length of firing time, in the case of normal bricks, is 1 day to 7 days, depending on that. And in the case of the fly ash bricks, it's a few hours. Now, why they don't give the whole hour? Because this is patented confidentiality. So they don't say that use this many hours, okay? So they will say, as to patent, go and buy the patent or rent the patent, something like that, that will give you. Okay. So this table is now that table once summarized the differences in the manufacturing process between the clay bricks and the flash bricks. A very important saving that can be readily seen is that of personnel. That means you don't need to employ too many people, because if you have to employ too many people, then you also have to have a large section there. Since neither excavation or grinding is needed, the personnel that are usually employed for such operations will not be required. So from the company point of view, management point of view, it's a gain. But to me, sometimes from the personnel point of view, it's a loss to the personnel. So I feel a bit sorry for that. But in India, it may not be that much effective, because all the people can be transferred to the other things, okay? Because costing is much more preferred here. Added to this is the need of continual assessment of the raw materials in the case of clay bricks, as we have said there. But such assessment is not needed in the case of flash bricks, because the fly ash is analyzed continually at the power generation station as a mandatory practice. So when the fly ash is coming there, you know what composition it has. So the personnel involved in the assessment of clay materials will not be required with fly ash or flash based production. So these are the advantages and less worries. Further market study of the items above is required, so that figures may be assigned to total savings with flash bricks. So now if people want to make, if you are involved in a company, or if you have your own company whereby you would like to make many structures and you need many bricks and you don't want to wait long time, if you use flash bricks, your waiting time is only, half of that of the normal bricks, because even just before curing, you have to keep it for 3 days instead of 7 days. So that itself is less than half of the time. So those things are advantageous. Now, this shows the production of flash breaks in the laboratory, repeated successfully many times, and the testing has produced consistent results. So this is the figure 1, which shows the molded bricks in the fresh state. That means they have not yet cured. Now, if you have a look at this bottle and that color of the bricks, are they quite similar, isn't it? Okay. These are normal bricks. Okay. Okay, thank you. So this shows, and there are also a little bit of small holes and things like that, which is there in the normal bricks also. So it's good that Professor Kamalkar brought a sample of this fly ash, so you can immediately see that these things are, and this is before firing. Yes. Dried means you have, after mixing with the water and the things, so normally, as I say, you put it for 3 days. Yes, you put it for 3, yes. Freshly molded flash bricks. So these are the molded ones and not yet fired, okay? The way it says fly ash and water. Yeah, that's what it says. Okay? But maybe sometimes, if there are any special things, people may have to go through the patent, and but as it says, it's mostly, you don't have to put any other things, the fly ash and water and fly ash. Because fly ash also actually can absorb the water. And hydrophilic, that is what is known as pozzolanic. Okay, so the water is not flowing, the fly ash actually absorbs the water. So the water becomes a part of the fly ash. Okay? So it may be inside the fly ash, there are hollow things. And you know, when you put some ointment on your skin, how does the ointment get inside? If you have a cut there, how does the ointment get inside the skin? Because of the air pressure, okay? Because the outside air pressure is one normal air pressure, and inside is much less. So the diffusion goes from high pressure to the low pressure. So that way, you are using water in the fly ash, so the water gets into normally. Okay? There? It will be fired later. This is freshly molded. This is not yet fired. We'll come to that. This is when we have put them in the mix the water and everything, and then keep it there for 3 days, and then after that remove the mold. That means you just take out the side things, and this is what it shows. Now you say that why there are some voids and things like that, because that is quite normal, because water goes inside, and sometimes water goes inside, and if you put it outside, sometimes if there is outside water, that goes back to the atmosphere. All right? So gas may be trapped. Yes. Okay. The next shows the figure 2, which has been now, this is after 2 days of curing. This is after 2 days of curing. So they have shown 2 bricks, only showing up and top, and here. And also I think they have actually cracked it there. You can see it broken out into 2 halves. Now the color has not changed. So that is one thing. The conventional bricks have nice red color, but these bricks have the color which retains the color of the fly ash. Okay, so this is, and you still see there are a few holes there and things, but that is the part of the bricks, and that's how. But these are the circular things like that. So even there is no longer cracks or anything, but there are holes. But then they when you cure them, so it becomes much stronger. The water, they forms the bonding. That is the figure 2. Figure 2 shows a brick that has been cured for 2 days before firing. That means it's the 3 days. And then the bricks will be fired after 24 hours, but are best fired after 3 days. Okay. So figure 3 is a photograph of the bricks after firing. So let's see how it looks like after firing. It still has the holes, but now the color changes. So after curing for 2 to 3 days, the color was the same, but now the color changes to halfway through the natural bricks. But those holes which we had outside, those holes are still there. But now it's a much stronger brick because it's chemically is cured or fired. Okay, figure 3 shows a photograph of the bricks after firing. The bricks color after firing is reddish and very similar to some of the observation of clay bricks. Of course, other coloring may be obtained by addition of selected oxides, but that means if you use other oxides, you can change the color. That's what they say, fly ash and water. And unless you want to use some other like coloring agents or some other oxides, okay? So then that's what they say. You don't need to have any binders. Because the water goes into the fly ash. The fly ash is pozzolanic. So the water actually gets automatically, it's a kind of a physical bonding which happens naturally. So that's what the fly ash has, this property, pozzolanic. So that means water automatically goes and forms a bond with the fly ash particles. And then when you fire it, anyone works with in the area of ceramics, sintering of ceramics? So at what temperature do you sinter the ceramics? And also at what temperature this firing or sintering is done? Yes, so typically between 1000 to 1500, something like that. And as was mentioned, this curing temperature is between 1000 to 1300. So now lots of things are happening when you put it there, curing there, okay, you're applying the fire, then the water, much of the water goes out, and the ceramic particles between which comprise the fly ash, all the list of ceramic particles, they start sintering and joining together. Yes, densification. So that's what happened then. Although we said fly ash, but apart from carbon, all the other components in the fly ash are ceramics. And when you are putting them together and when you are actually under pressure and you are curing or firing, those ceramics starts joining with each other. Okay? So it becomes a three-dimensional bonding. All right. And a lot of water is gone. So a series of testing was done on flash bricks in order to compare their qualities as load-bearing bricks with those made from clay. An Australian and New Zealand standard were applied for these tests there, and commercially available bricks that are known to be among the best in Australian market were tested and compared to the results. And these are shown in type 2, table 2. Come on, come on, come on, table 2, come on. Okay? So now we have the properties of these flash bricks compared against the clay bricks. If you take a look at the clay bricks, typical compressive strength is 12 to 40 MPa, and they have given PSI. What is PSI? Yeah, and in which country it is still used? I think it's only used in America. And because this conference was organized in America, so that's why. Okay? Yes. And as many times I've traveled to America, and even on the roads, they still use, many roads, they still use speed limit is such and such miles per hour. But in California, if you go, you'll find kilometers per hour. What do they do in India? Because they say speed limit is 30. IT can't put, lots of areas, speed limit is 30. Is it kilometers per hour or miles per hour? Okay, okay. Because even in this corner, there's a speed limit 30. So is it 30 MPa? Okay, thank you. Good. Thanks for letting me know. I'm not driving, but at least I make sure that I don't run very fast. Because if I run faster than 30 kilometers per hour, the police will stop me and fine me. Okay. Modulus of rupture. Modulus of rupture means when you break it, like Dr. Kamalkar, yesterday he showed all those graphs. So from there, when you're doing it, and modulus of rupture is that angle and also the upper limit. So it can be from less than 1 MPa to greater than 2 MPa. So it's not very high. Initial range of initial rate of absorption, water, clay bricks, typical range between 0.22 and 0.5 kg per meter square per minute. Absorption capacity is 5 to 20%, and average density is 1800 to 2000 kg per meter square. So which is about, I would say, 2 grams per cc, something like that. Now, this clay bricks, which they made, the compressive strength was 12 to 40 MPa, and minimum accepted by Australian standard is 7 MPa. So it was okay, clay brick. Now, if you go to flash bricks they make, compressive stress is 43 MPa. So it's as good as the highest value of the clay bricks. The clay bricks have lowest is 12 and highest is 40. But in the case of the flash bricks, the lowest and highest are about the same. Modulus of rupture for clay bricks 1 to 2 MPa, whereas here is 10. so about 5 to 7 times. Then typical initial rate of absorption, and here is 4.5. So it's quite good. Then absorption capacity, which is 10%, which is within the range. So it matches the ranges of the thing. And density, here, this is slightly heavier. So this is 18 to 2000, 1800 to 2000. This is about 1450. So it is about 20 to 25% lighter. Now sample of the best clay bricks, as they say, at 34.8, and then the 3.6, 5.9, water 6%, and this, but the density is still about 2 grams per centimeter cube. So this is, now these paragraphs explain the implementation of these above properties. The tensile strength used in the form of modulus of rupture in nearly 3 times value of normal bricks. So depending on the range. So this is for flash bricks. This is an achievement of considerable importance because it results in much less cracking of the bricks. So modulus of rupture means breaking or cracking. So if it has 3 times better strength, that means the flash bricks will crack much less. Such cracking, whether caused by differential settlement, excessive tensile nature bonding or things, has been a major concern in the building industry. The building industries, the normal bricks industries always wanted better properties of the clay bricks, but it was not always possible to achieve, but the fly ash bricks showed that yes, you can do it. So that is, so this is not the theory. We have gone through this, this is the practice. This shows the results. And again, the compressive strength is at least 24% better than the very best of the standard clay bricks. This is also a great significance because the new bricks may become the main load-bearing element that would be able to carry several floors more than allowed for normal clay bricks. And as I mentioned earlier, that in China, many story buildings, 20, 25-story building, they are now using this because they're light, so they're giving less weight, less load on the building, and also they are much higher strength, much better strength. Okay. So that is the kind of thing, and this is everywhere you go. 30, 40-story buildings. It's good that I don't see such tall stories here. But when I was coming from Lucknow to Kanpur by car, in some of the areas I could see these very tall buildings are going up. Maybe they can be asked to use fly ash bricks. Please, I've come here, I wanted to, so I'll go back, but please make sure that you people convert these concepts into technology, okay, through your contacts. If I can be of any help, that will be good, but I wanted to bring all this information, and the Gyan authority, I'm happy that the Gyan authority actually accepted my submission, and thanks to Professor Kamalkar and his team that we can share this information. Now, as we have seen there, the density of fly ash bricks is earlier 28% less than that of the normal clay bricks. This has great significance on loading floors, ease of construction, transportation capacity, and cost and number of bricks that can be produced per ton of raw material. So 265 bricks per ton can be produced from clay bricks, whereas another 100 bricks per ton can be produced from flash bricks. So you can make the same number of bricks and you can make another 1/3 of the floor using the flash bricks. Now we are coming to the initial rate of absorption and the absorption capacities. Because these are the theories, and that's what everyone asks the questions, that what happens, how do absorption and things take place. Two important properties of building bricks are the initial rate of absorption, IRA, and the absorption capacity. The IRA is of great importance for the laying of the bricks and bonding with the mortar. Now, the property of total absorption capacity is also very important for the performance of the brick. And the results obtained for the IRA and the total absorption capacity in flash bricks indicate excellent performance potential in laying and durability. The ease and efficiency of laying bricks is much more related to the IRA property, which also affects the importance of the bond to the mortar. So bonding to the mortar is important. What is mortar? Bonding two bricks? Something like that? Bonding the bricks, yes. So here the bonding with the mortar is much better, okay? So compared to the clay bricks, so that means that it is much more permanent, okay? It's much more stronger there. So that is the bigger advantage. Now, to do that, due to importance of bond characteristics, a series of bond tests were conducted on the flash bricks and the normal clay bricks. And the results, and this is what engineering is. You say that needs to be done, but people will ask you, what have you done? So this is a formula for calculation of bond strength. Where P is the maximum applied load, then Pi is the weight of the loading arm, L is the distance from the prism. So figure 5 and 6, let's go to figure 5 and 6. So that will show, okay. So this is this is figure 5. You have the bricks there, 5A and B. And you apply the load from there. And this is the retaining frame. So these are the bricks there. And you apply loading arm weight. You are applying the P, okay? And then when you do that, it tends to, there are two things there, two bricks there, and the top brick comes out like that. Okay, so that is what the test method is. These are standard mechanical test, materials engineering, and civil engineering. So A is while loading, and B is at failure. So you need to see at what load this failure takes place. And this is figure 6, details of the other clamping bracket. So these are so here is the brick and mortar joint, steel brokers, and upper clamp. So these are the different pictures of the bricks. And then when you have done the test, you do the test by, this is the load, there is knife edge there. So these are the details of the upper clamping bracket. So again, these are ASTM standard. I have not used this standard, but civil engineers need to use this standard. And this is a figure 7, which shows a close-up showing the texture in a slice from flash bricks. And this is one direction, this is the other direction. So this is how it looks like. And figure 8 shows a magnified view of the surface of the flash brick. The bubble impressions that still exist on this surface are much less than, there is a scale bar. This figure you have seen before. There is a scale bar there, but I'll just read it. The bubble impressions that still exist on the surface are much less than those that appear in a slice of the interior. Nevertheless, the surface indentations are believed to be responsible for interlocking between the brick surface and the mortar. So what it says that you had the mortar and you apply the thing and the brick came out. That means the mortar broke. And what they say that these are the example of how the bonded were there, and when the mortar broke, then part of it is coming out from there. So this is how the magnified surface looks like. The durability is the final part of this investigation. Resistance to salt attack was evaluated according to the Australian and New Zealand standard. A zero loss in mass after 15 cycles of exposure to soaking and drying was recorded. So there is zero loss of mass. This is very good, because this result was much better than the clay bricks, which had a slight mass loss after 15 cycles of salt exposure. So in the case of that, after 15 cycles, it has absolutely zero. But in the case of the clay bricks, it is at a slight thing. So this test, although employs sodium sulfates, and thus is a direct indication of the ability to resist sulfate attack. So this shows, this is an indirect kind of testing. This shows that fly ash bricks will resist sulfate attack. Okay, so you get it much. The cooling, the pre-sintering dead in the case of normal bricks are 7 days, but in the case of fly ash bricks are 3 days. And then after heat treatment to the same temperature between 1000 to 1200 degree centigrade, the normal bricks, and they have the same capacity, you use the same temperature, no difference, but the strength of the fly ash bricks is much better, much more than that, and also all the mechanical properties are much better. And in the case of fly ash bricks, there is no variation. In the case of the other bricks, the strength, depending on how many you did, it goes from 12 to 40 MPS. And how does it matter? Because the composition of the clay and composition of the sand, they all change, because depending on where you bring. But in the case of the fly ash, because you are getting from the same source, that value was typically about 42 MPa. So this test, the final test, durability, shows that the fly ash has much better durability than the normal clay bricks. This test thus is a direct indication of the ability to resist sulfate attack, and it's also indirectly indicative of the ability of the material to resist cycles of freezing and thawing. Now, why freezing and thawing is important? Because lots of countries go through very cold temperature and again coming back. So that can actually, durability, that can induce just shrinkage and expansion and things like that. But what they showed, that fly ash bricks does not undergo any such change, whereas the normal bricks undergo changes. So this work is a real good example and patented work, and it shows how to do the things, how you have to compare against other parts. And if you are working in different units, you do different units, okay? And so in conclusion, this work shows that the results are indicative of the satisfactory performance of flash bricks as load-bearing elements. This type of brick uses 100% fly ash without mixing with clay and shell. It therefore provided a large venue for the disposal of fly ash in a very efficient, useful, and profitable way. And you don't have to throw the fly ash into the soil and sound anything, and it's in the brick. So the health problems are much less. Now, as I understand, Professor Kaur has invited another medical person who will perhaps talk about the medical features of fly ash. So when you manufacture bricks and other things, everyone has to look into that. But in this case, the fly ash bricks is there. So all the things are cured and sintered. So that is one good aspect. So health problems for fly ash bricks should be much better than that of the normal bricks. The mechanical properties of flash bricks have exceeded those of the standard load-bearing clay bricks. Notable among these properties are the compressive strength and the tensile strength. In flash bricks, compressive strength was 25% better than the clay bricks, and tensile strength was nearly 3 times the value for the standard clay bricks. That's a fantastic thing, because normally clay bricks have much low tensile strength, okay? And the reason why the tensile strength is about 3 times more, remember I have been mentioning all this time, if there are holes there, the stress concentration is a factor of 3, okay? So if you have normal bricks, there are holes and the sintering is not that good. So even the brick components are made of ceramic, but because most likely because there are circular holes there, that creates a stress concentration of 3 according to fracture mechanics. In the case of these flash bricks or fly ash bricks, those holes are not there. So the strength is not reduced by any such holes. Okay, so that factor of 3 is a very interesting link. Okay, because if you have a circular hole, stress goes up by 3 when you're at that point. But if you don't have this, so that shows that the flash bricks do not have any internal circular voids. So that's why their strength, fracture strength or tensile strength is 3 times higher. That will be a very good issue. 3 times higher is fantastic, 300% better. Comparison between the bond strength of flash bricks to mortar and that of comparable shaped and commonly used solid clay bricks showed that flash bricks have a bond that is 44% higher than the standard clay bricks. So that is very interesting. So when you have done the sintering, you have taken to them, and that's where all the ceramic components, they get bonded much stronger. Okay, and these are all chemical bonds. That gives much better strength. So the flash bricks have a bond that is 44% higher than the standard clay bricks. Also, there is evidence that the microstructural feature of the surface of flash bricks is characterized by a rougher texture than that of the clay bricks. The characteristic is believed to be responsible for the increased bonding. Now, if you have a rougher structure, then you have more surface area. And then when you are using high temperature curing or sintering, then the bonds are much more. It's just this side, this gets bonded together, okay? So that rougher structure at room temperature, when you sinter it, that gives better bonding. The resistance of the brick to repeated cycles of salt exposure showed 0 loss of mass and excellent resistance to sulfate attack. So that's a good chemical properties of the flash bricks. And then the density of flash brick is 25% less than that of the standard brick. That means it's much lighter structure, but it's at the same time it's much stronger structure. It gives a good deal of savings, amongst which are the savings in the raw materials and transportation cost, and savings to the consumer that result from increased number of units and reduction. So if you have more bricks for the same amount of material, you can use them for more number of floors. So with normal clay bricks, if you are going to build up a certain numbers, let's say 10 floors, with flash bricks with the same weight, you can build maybe 12 to 14 floors. All right, so that gives you more. Yes, and the cost of the buildings and things and the premises of the flats also becomes cheaper for common people who want to buy these apartments. They can get it at a cheaper cost. The process of manufacturing flash brick clearly indicate that there is a much savings to be done during the making of bricks. These savings should arise mainly from the uniformity of the raw material, that is the fly ash, and the reduction of the firing time, that is only much less than that of the clay bricks, as well as from doing away with the whole process of mining, transporting, mixing and grinding that are necessary in the case of clay and shell-based bricks. So this gives a very solid example that not only ideas, but you have to produce things following the ideas. So this is our university, UNSW, which civil engineering. Our university has lots of bondage, say Australian Defence Force Academy. It could have gone to University of Canberra, Australian National University, which is based in Canberra. But they prefer to be a part of our university, University of New South Wales. And this shows that our university actually encourages people to do lots of new and productive work. Okay, and with that, I'd like to close my first tutorial talk, and back to you and Professor Kamal.